So, today we'll talk about like the disk types supported by NetApp, the and write groups. What are the write types that will support in NetApp? We'll talk about them. So before jumping into disk types and write types, let's talk about the disk architecture. Okay, how the disks will work, how the internal components of the disks will work. Okay, okay, disk architecture. So generally, hard disks will be like this. Okay, in a rectangular shape. Okay, and inside a hard disk will be having a circular component. Okay, there will be a circular component inside a hard disk like this. Okay, and to the middle of the circular component there will be a supporting component. Okay, there will be a supporting component. So this supporting component, we'll call it as shaft. So with the help of shaft only, this circular component will rotate. Okay, we'll call this circular component as block. Okay, we'll call it as block. Okay, so this block is when you open a hard disk, then only you'll be able to see this shaft, block, and all other components which are inside the hard disk. Okay, so this block is kind of, it looks like a cd drive, a bunch of cd drives. Okay, which will rotate uh, with the help of shaft support. Okay, and the performance of the disk will be decided based on the block rotation speed. If the block can rotate higher speed, then the disk performance will be high. Okay, if the block rotational speed is slow, then the disk performance will be slow. Okay, and along with these two components, okay, we'll be having another component called pointer. Okay, we'll be having another component called pointer. Having another component called pointer. So this pointer is the one responsible for writing the data. Okay, the block will keep on moving, right? Whenever the parts in the block reaches the pointer, then pointer will drop the data into the block components. Okay, this is how normal basic disk architecture, and this is how it will work. And let's assume this is a shaft, right? And as I told you, we'll be having a circular components towards around the shaft. Okay, this is I'm just drawing another diagram which will show you the side view. Okay, this is a shaft again. This is not that important, but I just want to discuss it here. That's it. Okay, shaft. And this entire component, we'll call it as a block. And the each layer in the block, we'll call it as a stripe. Right. Okay, this is how the architecture will be, the disk architecture will be. Let me show you diagrammatically like how it looks like. See, this is what we have discussed so far. This is a normal hard disk. Okay, the rectangular one, and inside we'll be having this is the block where actual data will be written, and this is the pointer, and this is a shaft which will be act like a supporting component to block. Okay, and this block is not a single component. Actually, it looks like a bunch of CDs, right? As I told you, see, have two components. Okay, this is how. Okay, now let's talk about different types of disks supported in NetApp, and after that we'll discuss about the write types and how they will work. Any questions on normal disk architecture? There is nothing you need to remember. Yeah, just want to let you know. Okay, disk types. So the first disk type is ATA, advanced. Mama, ma, advanced. Yeah, advanced technology attachment. Okay, that is the full form of ATA. So as I told you, every hard disk will be having a block, right? And as we discussed earlier, the rotation of the performance of the disk will be it will be depends on the rotations of the block. Okay, if the rotation of the block is high, then it will perform very well. So every disk will be having its own rotational speed based on the depends on the block speed. Okay, so this ATA drive supports 5,400 rotations per minute, RPM, rotations per minute. That means whatever the block inside the this ATA drive will rotate 5,400 times in a single minute. Okay, and there is an average IOPS supported by each and every disk. This is not exact value actually. Okay, this is a average value. Average value. So it will be like 50. Yeah, I think approximately 50 IOPS support. IOPS means nothing but whatever the operation, each and every operation that will be performed on the hard disk will be calculated as a IOP. That means I'm reading something from a hard disk, or I'm writing some data to the hard disk, or I'm playing a movie, I'm playing a what a audio file, okay, or I'm installing some application, okay, all these things will be considered as a IOP. So this disk can bear 50 IOPS per second in a single second. Okay, it can sustain up to 50 IOPS in parallel. Okay, if it crosses more than 50 IOPS, then it will add the latency to the disk, so it will become slow. Okay, next thing is data serial advanced technology attachment. That is the full form of SATA. So SATA, the rotation speed in SATA is 7,200 RPM. Okay, so it will support up to 75 IOPS. Okay, input output per second, IOP means. Next one is FC, fiber channel. Okay, and in fiber channel, when it comes to fiber channel, it has 2 RPMs. Normally in ATA and SATA, we have only 1 RPM, right? Either 5,400 in ATA and SATA. When it comes to SATA, it is 7,200. But when it comes to fiber channel disk, it will be available to you in 2 RPMs. One is 10,000 rpm. Okay, and the other one is 15,000 rpm. Okay, 10,000 rpm and 15,000 rpm. So when it comes to 10,000 rpm, it will support 125 IOPS per second, input outputs per second, because the RPM is less when compared to 15,000 RPM. Okay, it can bear up to 125 operations at a time. And the 15,000 RPM disk will support up to 175 IOPS, input outputs per second. Next model is SAS. The full form of SAS drive is serial, or I think system attached SCSI. Okay, that is the full form of SAS. Even in SAS also, it has two RPMs. It is available to you in two RPMs. One is 10,000 RPM, which will support again same thing like FC. It will support 125 IOPS, and another one in 15K RPM, 15,000 RPM, which will support 175 IOPS, input outputs per second. Next, after SAS, there is a drive called SSD. Sorry, SSD, or even we'll call it as flash drive. Okay, you can call either SSD or flash drive. The full form of SSD means solid state drive or disk. Okay, so when you compare SSD with other disks, normally the block and all internal components in other disks are moving, right? They are the moving components. Okay, that means the block will have rotations, and based on the rotations only, it will get the performance and all. But when it comes to SSD, there are no moving components in SSD. Everything is they'll be in solid state. That is the reason we'll call it as a SSD, solid state drive. That means there are no moving components inside the SSD. Everything will stay still. That's it. Okay. And when it comes to SSD, there will be no RPM, zero RPM SSD. Okay. And but when you compare SSD with other hard drives, it will give you very high performance when compared to normal spinning hard drives like SAS, FC, SATA, and ATA. Okay, so based on the disk size, SSD IOPS will be based on the disk size, and the SSD disk type will support from 3,600 to, okay, 6,000 input outputs per second. Input outputs per second. Input outputs per second. Okay. Yeah. Next. Recently, they have introduced another disk called FSAS. Okay, FSAS. That the full form is Fat SAS. Okay, this is a newer hard drive which is introduced from NetApp. It is a combination of SATA. They have used they have combined both the technologies, and they developed this particular hard drive. Okay, this is a FSAS, and again it will be available to us in two RPMs. One is 7,200 RPM. Okay, and which will support like 100 IOPS approximately. All these are approximate values. Okay, not exact values. And another one in 10,000 RPM. will support like 125 IOPS. Okay, that's it. These are the number of hard drives. I mean the disk types supported in NetApp. Okay, when it comes to AFF and ASA, only flash drives will be supported in AFF and ASA. Okay, all scenarios. Okay, but when it comes to remaining fast, all the drives will be supported. Okay, any questions, guys, on disk types?
Anaya,
Mhm.
I just need to clarify one thing about FSAS and SSD.
Mhm.
Actually, the RPM for SSD is 3200 and 3500 IOPS.
No, no, that is not RPM. SSD RPM is 0. SSD will be not having any RPM. It is a
Okay,
solid state drive. That means all the components inside SSD, they are not moving parts. Okay, they'll be in solid state.
actually, Anaya, here the approximate IOPS is 3200
Yeah,
and
3600 to
3500.
6000. Yeah, so SSD will give you a very good performance when you compare them with all other disk types. I mean, because SSD are designed with a different technology when you compare it with the spinning drives. Normal remaining drives are there, right? SATA, ATA, FC, SAS, FSAS. All these are, we'll call them as spinning drives because they are designed in such a way where the block in it will rotate. Okay. So based on the rotation speed only, the performance will be decided. But SSD, they have used a different technology where there will be no moving parts. Okay. So, when you compare the performance of SSD with all other drives, SSD will give you very high performance.
Okay,
They have
Anaya.
used a different technology than normal spinning drives. Yeah. Okay. Any other question, guys? Krishna or others? Amar, are you able to hear me? No. Let's talk about the RAID types. Okay. First, what is RAID? RAID means the full form of RAID is redundant array of independent disks. Okay, we'll call it RAID means redundant array of independent disks. That is the full form of RAID. Okay, before talking about the RAIDs, okay, we need to know few things. That is, we call it as data writing mechanism. Okay, mechanism. How the data will be written to the disks and all we need to know before proceeding with the RAID. So normally, what we discussed in when it comes to storage, what we are going to do, we are going to combine physical drives and we'll create a pool. That is what we have discussed, right? When we are talking about the storage overview, even if it is a NAS or SAN, it doesn't matter. We'll combine all the hard drives and we'll create a logical pool with the hard drives. From that logical pool only, based on the requirement, we'll create a small logical partitions and we'll assign those logical partitions to the clients, right? That is what we are going to do. Okay. So here, let's assume that, okay, I have like three drives. Okay, these are drives. Let's assume that these are the hard disks. I have three hard disks. Okay, I combined these three hard disks and created a pool. I'm just taking only 3 hard drives for my convenience. Okay, generally. Normally, you can put like more than that, 20 or 15, whatever number you want. Okay, okay. Let's assume that these are the hard disks. So this is a disk one. This is a disk two. This is a disk three. Okay, I have 3 hard disks. So these are the blocks. Okay, this is a actually block inside my hard disk. Block one, block two, block three, like that. Same here on disk two also. I'll be having different blocks. Okay, so we have two types of data writing mechanisms here. Okay, one is concatenation, concatenated or concatenation, whatever it is. Okay, so concatenation or concatenated. Let me write it as a concatenation. Okay, concatenation. So in concatenation, the data will be written to one disk only at a time. That means, okay, the data first will return to the first disk and it will complete all the blocks in that first disk. Okay, once the disk is full, then only it will go to the other disk. Okay, like this. Once second disk is also full, then it will go to the third disk. Okay, like this. So if you use a concatenation writing mechanism, then it will write the data to every individual disk, not parallelly. First, once the first disk is completed, then it will go to this other disk. That disk also filled with data, then it will go to the other disk. Like that, it will write the data disk by disk. Okay, it will write the data to one disk at a time in a concatenation. Okay, and we have another technology which we'll call it as striping. Okay, striping. So when it comes to striping, let me take the same example here as well. Let's assume that I have 3 disks here as well. Disk 1, disk 2, disk 3. Okay, so I have again, let's assume, I'm assuming that I have 3 blocks, okay, for my convenience, so that I can explain you properly. It will be having more blocks or less blocks based on the disk type and the disk size. Okay, the number of blocks. So here we got another thing called stripe. What is stripe actually? Normally every disk will be having different, I mean, multiple blocks, right? So we'll call the block we'll call the blocks across all the drives in a single pool as stripe. Okay, this is stripe. Okay, stripe 1, and this is stripe 2. Okay, this is stripe 3. Okay, like this, we'll call them as stripes. Okay, I'm just removing the stripes. So when it comes to striping data mechanism, the data will be written to all the disks parallelly, but in stripes. First, what it will do, it will write the data across all the blocks in all the disks. That means the first stripe of the disk. Once it is completed, then only it will write the data to the second stripe of, I mean, the other stripe of the all the drives. Okay. Once the second one is also completed, second stripe is completed, then it will go to the third stripe. Okay. This is how it will write the data in if you use striping mechanism. So which one you need to pick in fewer storage arrays, it is your decision to choose either concatenated or striping. But when it comes to NetApp will mostly use striping only. It will not give you the choice. Okay, it will not give you choice. Okay, simply let me explain you with an example. For example, let's assume that it is raining. Okay, you have three buckets here. If you in concatenation means nothing but you have kept one bucket on top of another bucket. So how it will fill? It will fill the first bucket, then it will fill the second bucket, then it will fill the third bucket. That is that is a normal real-time example for concatenation. When it comes to striping, we'll keep buckets side by side. So all the buckets will be filled parallelly, right? So this is how it will work. I mean, the real-time scenario, which I can explain you with a yeah close to concatenation and striping. Any questions on striping and concatenation? So if you use a striping mechanism, it will copy the data to all the disks in the pool. Like if you use 10 disks, then it will try to write the data to. It will distribute the data across all the 10 disks first stripe. Once the first stripe in all 10 disks is completed, then only it will go to the second stripe. Okay, like that. But in concatenation, it will write the data disk by disk. First, it will write the data to disk one. Once entire disk one is full, then only it will go to the second disk. So, which one will give you better performance? Which data writing mechanism will give you better performance? Obviously, striping will give you better performance when you compare it with concatenation, because in concatenation you'll be writing data to a single disk. Okay, will allow you to write the data to a single disk, but when it comes to concatenation, whatever data you are writing, for example, let's assume that you are copying just a 1 GB file. It will distribute that 1 GB across all the drives in that pool, so that parallelly it will write the data to all the disks, so that the data copy speed, I mean the time is very less. Okay, because it is just dividing that 1 GB into small partitions, and it is writing that data to all the disks parallelly. Yeah, any questions guys on concatenation and striping? Hello.
Yeah, Naveen. No, I'm good.
Oh, Yula, Zubair.
No, sir, nothing.
Oh,
Yes, Anaya, we are good now.
Amar, are you able to hear me? Can you please answer?
Yes, sir.
Okay,
Yes, sir.
cool then, thank you. Okay, now let's talk about write types, different write types supported by NetApp. So what is RAID? Again, let me repeat it. Redundant array of independent disks. Okay, redundant array of independent disks. So this RAID is useful, okay, to avoid the data loss during the disk failure. Normally, as I told you, what is the main functionality of the RAID? First, let's discuss about that. So here I'm just combining multiple disks and creating a pool, right? And creating a pool with these multiple disks. For example, if one hard disk got failed, hard disk got failed in this pool, then normally we will lose the data, right? Whatever the data we have in this hard drive, we are going to lose the data, right? This is how normally. But if you, while creating, we have a mechanism called RAID. Because of RAID, okay, because of a RAID mechanism, it will, there will be no data loss. Okay, we are going to see like why we don't have any data loss, and when we are going to apply this RAID to this pool, all these things. Okay, while creating the pool itself, we are going to apply the RAID mechanism, okay, which is ideal for us. Okay, but let's see what all are different type of RAIDs available and how they are protecting the data. Even why we are not going to lose the data in the event of disk failures. Yeah, we'll discuss all those things now. Okay, the first RAID type is, okay, RAID 0. Okay, RAID 0. The first RAID type supported by NetApp is RAID 0. So RAID 0, the name of the RAID 0 is stripe. Okay, stripe. So here in RAID 0, okay, I'm just taking 3 disks and I'm combining, I'm creating a pool with the help of 3 disks. Okay, let's assume that each disk has 3 blocks. That means total number of stripes I'll be having is 3 only. Again. Okay, so here it will write the data parallelly, right? RAID 0 means stripe. In striping mechanism, how it will write the data? It will write the data across all the stripes parallelly, right? Okay, GHI like this. Okay, so the minimum number of disks that we can keep in RAID 0, that we need to create a RAID 0 pool is 2. Okay, you need minimum 2 disks to create a pool with a RAID 0 protection. Okay, and do we have, do we really have protection here? No, right? Because if we lost this disk, I mean this disk got failed, then whatever the data like A, D, G we have in the disk, okay, we'll lose it. So that means RAID 0, if you apply a RAID 0 to a pool while creating the pool, okay, then the pool is not protected. Even a single disk got failed also, okay, we'll lose the data. So
So
all,
one, excuse me, sir.
yeah, yeah, yeah.
This disk one, you are considering it to be as RAID 0, right? In that case, whether if the
No, no. RAID is a mechanism which will be applicable to entire pool.
okay, okay,
So I'm creating a pool with 3 disks, sir. Okay.
okay, okay,
Normally, what RAID has to do? RAID has to prevent data loss from disk failure.
okay,
Okay. So here, RAID 0 will be not having any protection actually. RAID 0 is a useless RAID. So even single disk failure also it will lose the data. For example, here I just explained you like okay, first disk got failed.
Okay.
First disk got failed. Okay, so whatever the data I have in this hard disk, I'm going to lose it because RAID 0 is a unprotected RAID. It will be
Okay.
not having any protection. That is what. Even if second disk got failed, then we'll lose the data inside the drive, like BEH, like that.
Okay. Okay. Okay, sir. No issue. No issue.
RAID is applicable to all the disks in the pool. Okay. Yeah.
Okay. Okay.
So next thing is fault tolerance. That means how many disks, even how many disks failures it can tolerate. That means uh, um, how many disk failure we can, I mean, are negligible. Generally, when it comes to RAID 0, it is 0. That means it it is not even can tolerate single disk failure. That is a reason we are keeping it as 0. That means there will be no protection at all in RAID 0, and even one disk got failed also, we lose the data. Okay, fault tolerance means how many disk failures it can tolerate. It can, it will not lose the data. Okay, like that. But here it is 0 because even single disk failure also we are going to lose the data. Okay, yeah, that is a RAID 0. Next one is RAID 4. Okay, RAID 4. What is the name for RAID 4? RAID 4, we'll call it as parity. Okay? The name of the RAID 4 is parity. I'm taking the same example here again. 3 disks. This is disk 1, disk 2, and disk 3. Okay, I'm creating a pool with all these 3 disks. Disk 1 is these all are different physical disks. I'm just creating a pool with them. Okay, disk 1, disk 2, and disk 3. Okay, and they have blocks. Let's assume that these are the blocks inside my disk. As I told you, all the RAIDs in NetApp will work striping mechanism only, based on striping mechanism only. That means whenever you are writing the data, okay, it will write the data to all the disks across the pool. I have 3 disks, so it is writing data to all the 3 disks parallelly. Okay, and A B C D E F, these all I'm considering it as a data here. Okay, okay, okay. This is okay, and along with these data drives, okay, it will be having another thing called parity. Here I'm taking just 4 disk example. Okay, here I'm taking 4 disk example. We'll call it as parity. So in parity, how it what it will have? It will have all the data. So in normally in 3 disks, I have A, B, C, right? So in parity, I'll be having all the disks data. So in stripe 1, in all the disks, I have A in disk 1, in B in disk 2, C in disk 3 in first stripe. So it is a combination of all the data we'll be having in parity disk. So this is we'll call it as a parity disk. Okay, the same way in second stripe we have DEF, right? So in parity disk second stripe we'll be having D plus E plus F. All the data will be having in second stripe of the parity. Same thing here, G plus H plus I. Okay, like that. So parity disk contains all the data in the data disks. So we'll call these disks as data disks. Okay, this we'll call it as a parity disk. Okay, so parity disk contains all the data in data disks. So now we have a protection here. For example, let's assume that I lost let's assume that my disk one got failed. Okay, my disk one got failed. So whenever there is a disk failure in storage, it will be replaced with another disk. Okay, it will be replaced with another disk. So whenever we got a new disk, okay, whenever we got a new disk, uh, it is going to calculate it. It is going to do some RAID calculations. So we have a parity, right? Parity contains all the data. That means A plus B plus C minus B minus C. Then we'll get the data in this disk, right? That is how it is going to calculate and write the data to the replacement drive. Okay, the same way it is going to calculate do the calculations in stripe to D plus E plus F minus E minus F. Then we'll get the D, right? Actually, we don't need to do it. All these calculations and everything will be taken care by um, RAID only. Okay, G plus H plus I minus H minus I. Then we'll get the G, right? Yeah, this is how it is going to calculate the data, and it will write the data to the replacement drive. Replacement drive means nothing but the drive which is replacing a failed drive. Okay, so whenever any drive got failed in the pool, that will be replaced by a new hard disk, and automatically the data will be copied to the replacement hard drive by the RAID RAID technology by calculating themselves with the help of parity. Okay, so here parity drive means nothing but it is the drive which is protecting our data. Okay, which is protecting our data. So how many disks we need to create a pool with RAID 4? We require minimum of 3 disks. We need minimum of 3 disks. Have protection in RAID 4? Yes, we have a protection in RAID 4. So what is the fault tolerance here? What is the fault tolerance here? Fault tolerance is 1. That means there will be no data loss if a single drive got failed. But if more than that got failed, then obviously will be having data loss. Okay, so that is what we'll call it as a fault tolerance. So now I have I have told you how it will work with a single disk failure. What if what if we lost multiple disks failures? What if there are multiple disk failures occurs? Then obviously will be, I mean, RAID 4, the pool with RAID 4 protection will be not able to sustain from the multiple disk failures. It can sustain only a single disk got failed. But if there are multiple disks, like more than one disk failure, then it will be not able to sustain. Okay, I mean, we will there will be a data loss. Okay, and one more thing here. Normally, let's assume that this is a 100 GB drive, 100 GB disk. Okay, this is also a 100 GB disk, and my third disk, which is a data disk, this is also 100 GB disk. Then what will be the size of my parity disk? Again, this is also a 100 GB disk only. Then you can ask me, like, how come, like, how come 300 GB disks data can be adjusted into a single 100 GB disk parity data? Actually, the parity disk will not contain the actual data. Okay, it will not contain the, it will not copy, I mean, the whatever the data in these 3 disks, the original data will be not copied to the parity drive. Okay, only the logical data will be, logical differentiation of data will be copied. Like if you want to understand in depth how this parity and all will work, how parity can hold the data of multiple disks into a single disk. All this, if you want to know, just Google XOR. Okay, Google XOR and study it. Okay, because these writes and parity, this concept will work based on the algorithm called XOR algorithm. Okay, just study on your own, like if you are interested. Okay, this is a bit complex algorithm. Okay, like we don't require actually. Okay, this is designed by programmers and developers. We don't need to know in depth of it, but yeah, if you want to know, you are interested, then yeah, just go through that. Okay, Zubair, did you got it? Amar, Yula?
Yes, there is a little confusion, but just go through again and see.
No problem, like ask me like where you got confused.
Like actually, you said in striping technology, like the data will be shared across each and every disk actually.
Exactly.
Okay, in RAID 0, you said that even if one disk got failed, then the other two you will not be able to access anything actually.
Yeah, because the
Yeah.
entire pool will be down because
Okay. Okay.
it don't have any protection, right?
Okay.
Right?
Okay.
There is no protection in RAID 0. But when it comes to RAID 4, we have a protection called parity disk. So if one disk got failed, I have all the data in this parity disk, right? So
Yeah.
it can do a calculation. Like as I told you, A plus B plus C, I have in the first stripe. What it will do, it will minus the working drives, minus B minus C. So I got the data A, right? So
Okay.
that will be written to the replacement drive. The same thing with when it comes to second stripe, I have in the second stripe parity, I have D plus E plus F minus E minus F. Now I got the D data, right? So it will write the D data here to the replacement drive. So there will be no data loss. If one disk got failed, then the replacement drive uh, will get the data by with the help of protection. I mean parity protection. Okay,
Okay.
this is how. For example, let's assume that parity disk got failed here. No problem. The protection drive we lost it. No problem. Whatever the replacement drive which is replacing the parity, okay, the data RAID itself will calculate the data and write the data to the parity drive. So the RAID itself will know which disk got failed. Is it a data drive that failed or is it a parity drive that got failed? So based on that, it will calculate the data. So now we lost the parity drive. Parity drive got failed. No problem. What it will do, it will combine all the data again, A plus B plus C, and it will write the data to the stripe, particle stripe. Same way, D plus E plus F, and it will write the data to the replacement drive. This is how. See, RAID itself will come to know what is the role of the failed drive. So based on the role, is it a parity drive or data drive? Based on that, it will do the calculations and it will write the data. But as I told you, RAID 4 cannot sustain more than one disk failure. If two disks got failed at a time, then obviously there is a data loss. Okay.
Naveen, I have one more doubt here. Like, if two disks fail, we have the data in the parity disk, right? A plus B plus C. In that,
See,
we can't get back the data from the parity disk, even though if we got the two disks in RAID 4.
good question. You have the data in parity, but
Yeah,
it don't know, right? Like where to write the data. For
yeah,
example,
exactly. Yeah, yeah.
A is in which disk, B is in which disk. It don't know, right? And again, here I'm explaining you in ABCs, not generally,
Yeah,
but normally data will be in small blocks actually in
digitals.
real
Yeah,
time.
zeros and
It
ones. Yeah,
don't know which all blocks belongs to disk one, which all blocks belongs to disk two, right? So yeah, that is the reason. If there is a two disk failure, obviously it will be not able to sustain. Yeah.
yeah, got it. Yeah, thank you.
I mean, you need to take help of a vendor to bring it back again, the entire pool. They can help you, but we can't do it on our own.
Yeah, yeah, got it. Yeah.
Zubair, is it clear?
A little confusion, but we just go through again and see what it is actually, because this concept says
Yeah, yeah. Okay, no problem. Okay, RAID 0 and RAID 4 completed. Now let's talk about another RAID called RAID DP. RAID DP. So RAID DP, we'll call it as dual parity or or diagonal parity. Okay, we'll call it as either dual parity or diagonal parity. So when it comes to RAID DP, just taking 5 drive example. Okay, let's assume that the ones in the green color, let's assume that they are my data drives. Okay, ones in the orange, they are my parity drives. And when it comes to RAID DP, as I told you in the name itself, dual parity, that means it will be having two parity drives. They'll be having RAID DP will be having two parities. This is my data disk 1, data disk 2, data disk 3, and this is my parity 1, parity 2. Okay. Let's assume that uh, here the data will be, let's assume that A, E, C. So in parity, normally in first parity, it will be like A plus combination of all the data, right? A plus B plus C, like that it will write. Second parity, I'll talk about that little later. Okay. D, E, F. Same thing. D plus E plus F. D plus E plus F. Okay. And the third step, G, H, I. So again here, it will write all of them. G plus H plus I. Okay. Sorry. G plus H plus I. Okay. This is how normal parity. It will do the parallel calculations. It will write the data parallelly, A plus B plus C, like that. But when it comes to second parity, as I told you, we'll call it as a diagonal parity, right? Diagonal parity. Right? DP means either we'll call it as a dual parity or diagonal parity. So here what it will do, it will in the second parity, it will calculate do the diagonal calculations. That means it will do like this. Okay. A plus B plus I. Okay. Next one is C plus H plus C, like that. Okay, it will calculate the data diagonally. G plus B plus F. Okay, like that. This is how it will calculate the data in second parity, which is a diagonal parity. So here my write DP can sustain up to 2 disk failures because I have two parities, right? One is a parallel parity, which is a first parity, and I have another parity which had diagonal parity. So as I have two parities, it can sustain from 2 disk failures. Okay. So so Do I have protection here? Obviously, we have double protection here. Yes, there is a protection. So, how many disks required to create a pool with a write DP? I need minimum of 5 disks. And what is the fault tolerance? Fault tolerance here 2. That means even 2 disks got failed. Also, there will be no data loss in write DP. Okay. Any questions, guys, on write DP?
Yeah.
Next. Yeah.
Anaya, I have a small doubt.
Yeah.
In RAID DP means minimum 5 disks means only data disks want to be 5 or
No.
including
And
parity dual
in
parity total disks want to be 5?
good question. All of them, including parity.
Including parity.
Yeah, including parity.
Okay, okay.
Yeah. Minimum. If you put minimum 5 days, then it will automatically divide them into data and parity. Okay. For
Okay,
example,
okay.
you created with 6 na, then there will be 4 data disks, 2 parity. If you created a pool with 7, then 5 data and 2 parity. If you created with 8 drives, 6 data, 2 parity, like that. 20,
Okay,
then
okay.
18 data, 2 parity, like that.
Clear, clear.
Yeah. Next. Next one is RAID TEC. This TEC, will call it as a triple parity. So here, okay. So green ones in again data drives, orange ones in parity. Orange, the circles in orange. So it's, it's I'm assuming that it has 4 blocks, 4 stripes. Okay. So A, B, C, D. So you know that, right? First parity. So this is a parity. This second parity P2, and this is a third parity P3. In right TEC, we'll be having 3 parities, and all these are data drives. Okay, D1, data 1, or else D2, D3, and D4. Okay. So in P1, normally it is a parallel parity, right? That means A plus, B plus, C plus, D, right? And you know P2 also, but we'll do P2 little later. D, E, F, G. Okay. H, I, J, K. Okay. L, M, N, O. Okay. Like that. And in first parity, you know already, it will be parallel, like D plus E plus F plus G. And in third stripe, it will be again parallel addition of all of them, h plus I plus j plus k. Okay, same thing here as well in fourth parity as well, l plus m plus n plus o. Okay, now when it comes to second parity, it will do the calculations, it will do it diagonally again, a plus e plus yeah, not a plus will do a plus e plus j plus o. Okay, it will do like this. Generally I'm just giving you an example, a plus e plus j plus o. Okay, okay, next e plus I plus n plus sorry, I took it two times. Okay, that's fine, I just want to take an example, right? That's it. Then d plus I plus n plus, let's assume one is x. Okay, I'm just taking it as x. Okay, like that, same thing here, just it will do diagonally. Parity 2 will be calculated diagonally, just like a dp. Okay, what about a parity 3? Parity 3 will be calculated reverse diagonally. Okay, parity 3 will be calculated reverse diagonally. That means t f I l, like this. Okay, like this. Okay, like this. Okay, it will do the calculations reverse diagonally. Okay, just don't want to spend time by explaining all these again, calculating this. You don't need to do these things. Okay, everything will be taken care by right in the background, your right technology in the background. Only thing is, yeah, you need to know how it will work. That's it. Okay, so now, do we have protection here? Yes, obviously we have a protection in write TEC. And how many disks we need? Minimum number of drives to create a write TEC, 7. Okay, and what is the fault tolerance? Fault tolerance is 3. That means if you apply a write TEC to a pool, it can sustain even 3 disk failures as well. Okay, 3 disk failures. Okay, any questions, guys? Zubair, just go through the video. If you don't understand, let's have a call. Okay,
Okay, sir. Okay.
any questions, guys? Yeah, so yeah, so these are the write types, write 0, write 4, write dp, and write tec, supported by NetApp. Yeah, this is how they'll work. And all these writes will work, not only these writes, whatever the writes, they'll work based on the XOR algorithm. There is an algorithm called XOR. Okay, EMC, NetApp, HP, Hitachi, IBM, whatever, every organization will have rates. Okay, every storage vendor will have rates. Only thing, all of them will work similarly, but only thing is they'll customize these rights according to their convenience. Okay, yeah. Okay, just go through the video like again if you have doubts. If you don't understand, let's discuss it. Like if you have some questions or something, yeah, let's have a discussion tomorrow as well. Like if you
Annaya,
don't understand, yeah.
can you please explain RAID 6 also? We can find the difference.
Yes, so Normally in NetApp RAIDs, all RAIDs are dedicated, having dedicated parities. Dedicated parity. That means parities will be in a single drive. If it is a RAID TC, RAID DP, or RAID 4, only the disk will be having that parity. For example, let me take a RAID DP example. Okay, I have 5 disks. Okay, this will be my parity disk, and this is my dual parity disk in RAID DP. Okay, but when it comes to RAID 6, actually RAID 6 is not belongs to NetApp actually. Okay, RAID 6 is a sorry, EMC RAID. Okay, EMC. It will be not applicable to NetApp storage devices. But I just want to explain you because this is a good interview question that they'll ask you the differences between RAID TP and RAID 6. So normally how it will work? A C in parity will be having all the data A plus B plus C. Okay, right? And in parity 2 will be having diagonal data. I'm not going to calculate that. But when it comes to RAID 6, okay, same thing. I'm taking the same example as 5 disks. But in RAID DP, I can tell them which is a parity drive and which is a D-parity. That means a dual parity drive. But when it comes to RAID 6, okay, let's assume that A, B, C, this has A plus. I'm not going to do calculations. Let's assume that this is a P1. This is a second parity P2. Okay, like that. Okay, parity 1, parity 2. Next drive, in next stripe, okay, when it comes to next stripe, the data will be is copied to the first drive, second drive, and fifth drive. And this time parity is distributed across first drive, sorry, third drive and fourth drive. So when it comes to RAID 6, we cannot say this is a parity drive. We cannot say this is a D-parity drive because in each and every stripe, parity and D-parity will be distributed across all the drives. And when it comes to third drive, okay, okay, here we'll be having parity, okay, like that. So in RAID 6, what is you need to say the answer like this, okay? In in RAID DP, we'll be having dedicated parity and dual parity. But when it comes to RAID 6, the parity will be distributed across all the drives in different stripes. Normally, this is my R stripe 1, right? Okay, let me try it. This is a stripe 1. So when it comes to stripe 1, which all disks contain the parity? Disk 4 and disk 5 contains the parity, right? Okay. Now, if you take a look at the second stripe, where is the parity now? On which disks we have parity? Disk 3 and disk 4. Now, third stripe, which all disks contains the parity? Disk 2 and disk 3. Like that. Parity is distributed across all the drives in different stripes. But when it comes to RAID DP, if it is a stripe 1, stripe 2, or stripe 3, it doesn't matter to me in RAID DP. Everything will be in the single drive only. My parity 1 will be in the single drive and parity 2 will be in the single drive only. Okay, is it clear, Beulah?
Clear, Annaya.
Hello. Okay. Yeah. So yeah, this is a good interview question actually. What is the difference between RAID DP and RAID 6? Okay. Yeah, if you don't have any questions, then let's stop the session for today. Just go through the video. Yeah, if you still have doubts or if you don't understand something, then we'll discuss it again tomorrow. Thank you.
Okay, thank you.
Yeah.
Thank you.